ENA asked if I would champion the asset management power and improvement initiative for this year, which I was very happy to do. In terms of what power and improvement is, so obviously quite a few of you around the table are recognised from various events, and you'll be well aware of power and improvement. Not everybody is, and the more we can communicate what it's about in terms of being cross-sector, whether you're an employer or employee, trade union, whatever your sort of representation, it is about us all aiming to work together, for the good of safety in the workplace. So in terms of the background to power and improvement, where we are 2015 to 2019, it's a sort of rolling five-year plan with a sort of check year. So 15 was about contractors, 16 occupational health, really good output from that. Again, if you go to the ENA website, there's some really good OC health guidance there, and like an interactive roadmap. I think it's fantastic. Asset management this year, next year human and organisational factors, and then 19 again, it's a check year, review progress, what are we doing for the next 5 years. So this is a continuous process. You've all got input to that. When we get to 19 and the review progress, what are we doing next? All of the organisations represented around this table have got an opportunity to say what you think is important. It's not about Western Power Distribution's view or the ENA view, it's about a collective view. And the corporate memory is a really important part of what we do in power and improvement, but also ENA sort of safety, the safety team there, because it's very easy, as we all know, to things happen, people are injured or worse, but it's a generational thing. Apprentices come through, well, they weren't around when that happened 5 years ago. So unless somebody explains it to them, they've got no knowledge at all of it. And then something else happens and the next generation don't know about it. So it's really important. It's not sort of a doom and gloom message.
I work in Northern Power Grid in asset management, but even though I've got asset management in the title, I'm not the only bit of the business that does asset management. And it's important to recognise that asset management is a life cycle thing. You need to get it in your mind. It's not just planning at the beginning and setting the policies and letting things go. There's a lot more to it. But you do need to specify your systems, and some of those people are sitting in the part of the business I'm in, and the design. So we get involved in the technical design. Other parts of the business do the detailed physical design. You've got the installation, operation of the equipment, maintenance, investigations on equipment, repairs, and ultimately decommissioning and hopefully replanting, and we start again specifying what we want next, design, install, and so it goes round. So how does trade union involvement get in there? Well, all our members are involved in all of those activities, and the 4 recognised trade unions all contribute together. So we are really the eyes and ears of the company, and we've got our important role to play in our own safety and other people's safety. So the company recognises the benefits of the trade unions in terms of it's someone where a collective voice can come together and share issues with the company, but it works both ways. The company can use those representatives to actually share messages and get things across back to the workforce in a different way from the direct management structure.
Now, for those of you that don't know me, I'm Richard Goff. I'm the Head of Safety, Health and Environment at Scottish and Southern Electricity Networks. I've been with SSE just nearly 2 years now, but in the industry a lot longer, even though I still look very young, of course. Everybody nods at this stage, yeah. So this incident was really harrowing. I picked this up in my first months, and probably my first 6 months spent in my employment with SSE was dealing with this incident and liaising with the regulator, the police in Scotland, and lots of colleagues. And that was 3 years after the event. So just to set the scene and say that this was not our best hour in SSE is the truth. And since that, we have we've done the right thing. And in the spirit of today and the whole power improvement strategy for our industry, we're sharing information. So where did it start? Well, back in 2011, our transmission business, Scottish Hydro Transmission Limited, we basically let a contract, and the contract was to refurbish one side of a very long 275 kV twin circuit overhead line. In our promotion of the learning around this, we've tried to just very simply illustrate how all of these things would have contributed, all of the things that we found and that our colleagues elsewhere found contributed towards the actual accident. And of course, we've gone back to a very simple model of a series of control measures and the things that broke down. So this is the diagram that we've used. So in summary, this was an accident, and this is very high level. As you would imagine, there are lots of detailed points, but the planning of this actual job and the permit to work detail was not adequate. The supervision from the permit to work recipient, the competent person in charge of the working party, also was not adequate. The additional earthing arrangements, the type, the position, the process of applying and removing, etc., was inadequate. And the challenge and the general human factors was also inadequate. And often that's the last barrier, of course, between people and an incident. And so the accident occurred.
Good morning all. My name's Ian Burley. I'm an inspector with the Health and Safety Executive. I'm an electrical engineer. I'm a chartered engineer. My background is in the industry. I used to work for National Grid. I've now got nearly 20 years in HSE. I've seen a fair few incidents and I was given the task of providing an expert witness statement for the Beaulieu-Dounreay fatal incident. So my experience here was to be given around about 100 statements from those involved in the incident and about 3-4 foot's worth of evidence that was gathered as a result of this incident. And I produced a report on that basis. It was about 78 pages long, and I've got 10 minutes to summarise some of those issues. So you'll appreciate that I've not kept in too much detail, and I've stuck to some of the more sort of wider ranging points. So to reinforce that, this is a simple instruction. How did this become interpreted so differently? And on that day, there were, I think, 6 permits issued to workers on that line, to different gangs. So that's 6 competent persons receiving permits. There's the SAP who issued all of the permits. 7 different people seem to have a misrepresentation of the way in which this work was going to be carried out. This is on the same day, the same site, same job.
My name is Gus Carroll from Centrica, as Mike mentioned, and my role there is Group Head of Process Safety. And you may be curious as to why somebody who is primarily involved in oil and gas is talking at a conference about asset management in the electrical networks industry. Well, hopefully, as you'll see as I go through this presentation, which is really about managing creeping change, that the lessons we learnt from what I'm going to talk about are directly relatable and relevant to all asset management. It just happened to occur in the gas processing industry. And what we find is this type of situation of creeping change is particularly prevalent on ageing assets. And I'm sure you operate many ageing assets, we certainly do. So why did we focus on this? Well, in 2015, we had a very serious incident at our Barrow gas processing terminal up in the northwest of England, whereby we nearly killed 3 people. It was the most serious high potential near miss we've had in our history. The root cause analysis showed that creeping change was the fundamental root cause, and creeping change led to the failure of 6 key safety critical barriers. So what were the key findings of the work? So first of all, creeping change is accumulation of small changes. They tend to be gradual, they tend to be unplanned, they tend to be difficult to spot, but cumulatively they can add up to a very significant change. They're difficult to detect, they're difficult to monitor, and traditional methodologies such as process hazard review, hazards, HAZOPs really don't do the trick. Therefore, the work developed a specific methodology which can be used alongside normal risk assessments, which we called, unsurprisingly, creeping change hazard or CC hazard.
I'm head of asset investment management at EA Technology. My background is I've spent all of my career working with high voltage equipment, but as a specifier and a designer. So I spend most of my time thinking about what things should be on the system, but very little time actually using them, and that probably makes me part of the problem. So hopefully you can. What I'm going to do is show you a little bit, share with you a little bit about how asset management processes work, what asset management is, and give you an example of how, when asset management's done correctly, it can bring about huge change. And what I hope is that with the right approach, asset management can bring about a similar change in safety as well. There are some technologies to help us in this new world. Certainly, active assets as opposed to passive assets can detect faults, catch them before they start. If they do detect a fault, they can route the electricity in a different way and have the power back on before you know it. So there's less operational involvement there in keeping the lights on. Now, from a safety point of view, that's a good thing, because working safely when the pressure's on, when time is pressing, is just never good. Right. I'm going to share with you an example now of a company that have used asset management techniques very effectively. You may be aware of them, you may not. It's not a safety example, but what it is, it's an example of how asset management thinking, using this end-to-end approach, absolutely transformed the way a company worked in a way that I wouldn't have thought was possible had they not already done it. Their absolute number one priority was supply reliability. A lot of their industry and a lot of their economy is dependent on high value manufacturing, and it was fundamental for them that they had an extremely reliable source of power. So 0.74 is vastly better. 45 seconds versus 30 minutes, that's a huge difference. Yet the result was that there is 100-fold improvement in service here. This is fascinating. I mean, we'd be happy with 10%. And so it shows how by using this very clear objectives and making sure that it impacts on every part of the company, not just operations, how when it all comes together, it took them 20 years, but the step change in what was achieved is beyond anything that I would have thought possible.
So I was asked by Paul to just put something together on low voltage cutouts as to see where and what the industry is doing in respect of its strategy associated with it. So some of you are probably already aware of what we're doing, but basically the purpose of the cutout is to provide a safe and reliable supply terminal to properties, to protect it from faults on the network, means of connecting suppliers to the buildings, de-energising and isolating supplies, and also appropriate an earth connection. So there's an awful lot of continuous improvement. I've taken this from various ENA documents as to exactly what we're trying to do and how we're trying to do things. So, the DNOs are comfortable with the appropriate mitigations that are currently in place, but we want to improve. Continually look for new ways in which we can monitor. Smart meters is potentially one way in which we can see usage. There may be ways in which, going forward, smart metering may be able to help with condition of assets, going forward into some sort of version 15 of the smart meters. I know there's several versions already gone out that are smart, but not smart enough to communicate with the wider world in a format that we necessarily want. So there's always ways in which we can look at improved benefits associated with that. The inspection could be based on any intelligence that's come out from the DNO working groups. So you could look at a certain type of termination in a certain environment, could be more hazardous than another type. So it's looking at those sorts of scenarios and learn from each other's experiences that could also then come from some of the forensic examinations that have also occurred. So it's almost weighting some of the activities, the environments, the types of properties or load that's been experienced to see whether there's any further degradation of the asset that you would normally expect to see in certain other types of scenarios.
Okay, I'm Mark Taylor. I'm the HSES Director for Centrica, Distributed Energy Power and Energy Marketing Trading. So there's a few apologies. As you may note, my first language isn't English, it's Hull. Okay. And the second one, really, apologies. I often walk around when I'm talking, but you've engineered that out today, so well done. And the third one, really, is that I'm only 1 year into the industry. I don't have a technical background. I'm actually an industrial and occupational psychologist who specialised in safety. And you may start thinking, well, what psychology got to do with something that's very engineering based? Well, hopefully that'll come clear during the course of the conversation. Really, what was the common theme between those? Because they're all very different technically, but actually when you look at the reasons behind some of those disasters, it's safety culture and behaviour played an equal, if not more prominent role than any technical failure. Now the key thing about this is quite often there's a bit of a misconception when it comes to human error. And the misconception is it's all about the front line. It's all about the mistake that the individual made at the point of risk. Again, when we start looking at these things, and especially if we relate it back to the Reason Swiss cheese model, are you all familiar with that model? Yeah, good model. And we all look at the active failure. But how often do we actually go back and say, what was the latent condition? Because those things are related to decision making. Then we got another problem, because with all our inspections and all our KPIs and things that we can measure, we're quite often suffering from another problem called confirmation bias, where we think we know what the truth looks like and we seek information that confirms the truth rather than seeking contraindications. So I just wanted to take away about the psychology of asset management, and we see it in other places where we start talking more about the psychology of process safety, that decision making about the way we decide to manage an asset can actually blind us to risk.
Yeah, I'm John Berry, innovation engineer at Western Power Distribution, and it's sort of fallen to me to discuss around some of our innovative assets and the integration of those onto the network and the role of the SAPs. And I'll start by saying I'm not and never have been an SAP, so that will probably become clear as we discuss, and how I end up producing the documents of how we operate and control those without actually being an SAP. So yeah, a little bit about myself and sort of why I'm stood here is I work in our Future Networks team, manage a portfolio of projects that principally look at some of our larger technologies integrating into the 11 or 33 kV network, and some of that experience hope to share, and how we've come to a sort of a common methodology and approach to getting new technologies connected to the network. And most importantly, I'd be interested to hear what some of you guys, the approach you take, and perhaps how we can all improve. Earlier installations, so some FCLs and the StatComs, what we did was we identified that these were sort of isolated instances of installation. These were principally funded through Low Carbon Networks Fund projects, or NIA, or latterly NIC as well. And we identified that these were a one-off installation as part of a project trial, and we originally said that these were going to be in one location. The best way for these to work is have a specialist or a small handful of specialists in the area that operating under our normal safety rules and procedures, that had the local knowledge of how these devices were going to be operated and maintained on the network. So we were happy that that's a safe and reliable methodology for operating these, making sure they're connected appropriately. The challenge came then for us to say, well, what should we be doing by having these as isolated installations? Well, what could we do differently? That obviously isn't the case when we have thousands of pieces of switchgear transformers on the network. We don't have certain specialists who just deal with certain elements in widespread. So if we were forecasting that these technologies, as how we've sold these projects to Ofgem essentially to fund, how are we going to make sure that we were in place to transition through to business as usual while making sure it was safe for a wider range of people to operate the system? The issue then is if we're working on big documents that have come from manufacturers that perhaps don't understand how we operate our specific networks, and that document would be the same whether it was an R network, UKPN, or somewhere in Germany, France, wherever. How do we need that interpreted? So we looked and said documents to manage the specific device, and then finally we think we're getting somewhere to understanding that in terms of documents supported by the appropriate training that goes behind it, and making sure that all that's happened and we can get the device suitably connected and operated onto the system.
So this is just a little bit about what we do, and this is about human performance, leadership development, health and safety, the traditional stuff, but also what we're looking at is this new concept of safety differently, or safety 2, which some of you might have heard about, and it just has a different sort of flavour around about the worker and how we as management and as leadership set our workers up to either succeed or fail. We run a number of open training events in these sort of specialist areas, and we're working with a number of clients around the world at the moment. And human error is another form of business risk which can be mitigated. So very often we talk about human performance and we dive straight into safety. We think about safety. Actually, human performance is about all business effectiveness. And if we can make sure that when we set our people to work, that we're setting them up to succeed instead of fail, there are lots of benefits for us to reap from being able to do that. However, when we apply a human performance evaluation investigation, what we actually find is that of that 80% section of that pie, 70% of the times when we have a human error event, there is an organisational weakness that has set that person up to fail.